All right, this is the 2006 AMC 12A problem 25. How many non-empty subsets S of the set 1, 2, 3 all the way to 15 have the two following properties? No two consecutive integers belong to S, and if S contains k elements, then S contains no number less than k. All right, so first let's focus on condition number 2. If S contains k elements, then S contains no number less than k. So what does this mean? Let's say S has 6 elements, then it must be a subset of the set 6, 7, 8 through 15, where no two consecutive integers are, or there are no two consecutive integers. And the reason why this is important is because it's impossible for S to contain more than 5 elements. In the case where S contains 6 elements, it must be a subset of these numbers, 6 to 15. And you can try the subsets, but this is impossible. The max cardinality in this case would be 5. For example, you could take 6, 8, 10, 12, 14, and you only have 5 in this case. So now we can simplify this problem down to 5 cases. We don't have to worry about the case where S has 0 elements because the problem states that it is non-empty. So our 5 cases are where S is 1 element, S is 2 elements, all the way to S is 5 elements. So let me just write this down here. Okay. So case 1, S has 1 element. Well, this is the most simple case. If S is 1 element, then it can be a subset of the set 1 through 15, since S has to contain no number less than 1, so 1 still works. And since S is 1 element, the number of ways to do this is just 15. You could have just like a subset of 1, set of 2, set of 3, etc. Okay, now let's say S has 2 elements. This gets a little more tricky because we have to worry about condition number 1 now. No two consecutive integers belong to S. Now, the simplest way to think about this is using complementary counting. We first find the total number of subsets with 2 elements, and then subtract the ones where 2 numbers are consecutive. So if S is 2 elements, from rule number 2, it must be a subset of the set 2, 3, 4, all the way to 15. And this is 14 elements, because 15 minus 2 plus 1 is 14. The total number of subsets with 2 elements of this set would be 14 choose 2. And the number of ways to make a subset with 2 consecutive integers would be 13. For example, 2, 3, 3, 4, all the way until 14, 15. And you can count those up, that's going to make 13 in total. So for the case 2, we have 14 choose 2 minus 13. And you can calculate this quickly. This is the same as 7 times 13 minus 13, which is 6 times 13, which is 78. Okay, so that's that case done. Case 3, S contains 3 elements. So first, S must be a subset of the numbers 3, 4, 5 through 15. And the way we can think about this is using a trick called stars and bars. If you haven't heard of it before, you can search it up on the Art of Problem Solving wiki. So we have 13 elements in this case. And I'm just going to write them out like this. It's like we have 13 balls or stars. Let's say we choose 3 elements. I'll just shape them in. To guarantee that they're not consecutive, we have to add one of these balls between both of these spaces, so like this. And now this takes up 5 of the balls or elements, and so we have 8 left. So now we just have to figure out the number of ways to put these 8 remaining balls either here, 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 or here. And we can use stars and bars to figure this out. This is the same as saying we have 8 stars, 3 bars, and that's going to be equal to 11 choose 3, which is the same as 11 times 10 times 9 over 3 times 2. You can just simplify like this, and that should be 165, I think. Okay, and we can just repeat the same trick for cases 4 and 5. So in case 4, we have the set from 4 through 15, which is 12 elements. And let's say we have 12 balls. We choose 4 of them, so I'll just shape them in like this again. So we can write them down here. To guarantee that they're not consecutive, we put 3 of these balls, or 3 more from here, between them. This takes up 7. So we have 5 balls left. So that's going to be 5 stars and 4 bars. And this is 9 choose 4. Now I'll just calculate this again. This is 9 times 7 times 6 divided by 4 times 3 times 2 times 1. 3 times 2 cancels out the 6. 4 cancels out the 8. So this is the same as 9 times 14, which is 126, I believe. And our final case is where S has 5 elements. So again, I'll just do the exact same thing. 5 through 15, 11 elements. And so let's say we have 11 stars. We pick 5 of them and guarantee that they're not consecutive. And then this takes up, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 2 remaining stars, and 1, 2, 3, 4, 5 bars. So this would be 7 choose 5, which is equal to 7, or you can say this is also equal to 7 choose 2. And that's 7 times 6 divided by 2, which is 21. So our answer should just be all of these 5 numbers added up. And I'll just add them really quickly. 26, 78, 21, 15, 11, 19, 20, 25, 8, 10, 17, 20. So 405 is our answer, and I believe that corresponds to answer E.